sign in your attendance. I'll give you the code 301673. And for those who are in campus, just in case you still have physical class later, you can sign in using the code. For those who are not there, later the class end, remind me, I take attendance. So any more tutorial group need to change class now? Anyone still on the way to change class? If not, I will start. Because I see some still not yet join, quite a lot. %11. This that day, when did our lecture? Yesterday, right? Yesterday we have gone through our chapter 4. So let me show the screen now. We have done with example for the step transition function for the deterministic finite step machine. This one, right? We have done. No, this is the non-deterministic. And we have the example for the deterministic finite step machine, which is this. Okay? So you all need to show the steps like this for the deterministic. And for non-deterministic, actually we still have the example which not yet done. I think we will finish that first before we go to the new chapter. Okay? And we have stopped at this part, right? We stop at this one, example 12, correct? So I will continue with this example here, where they ask for the non-deterministic finite step machine. This is non-deterministic, and then they ask you to construct the step transition table of the machine. So we will just follow this diagram and construct the table. Okay, so I will show you first. I believe some already know how to do. So we try the table first. First one is Q0. And then the input we have A and also B. So here Q0 we have Q1, Q1, Q2, Q3. Each of them, we will see what happened after the input A and B. So for the Q0 here, after input A, it will go back Q0. And the Q0 also, after input A, also go to Q1, right? So here you have two, Q0 and Q1. Then for the B, Q0 after B, it will go back to Q0. Then Q1 after input A, go to Q2, one only, and input B also go to Q2. Then for Q2, after input A, go to Q3, and no input B, so this one is empty set. Q3, both the AB also go to Q3. So here you can see that because of the Q0 of the input A goes to two different steps, and Q2 after input B go to none. So this is a non-deterministic finite step machine. And part A is this one. They ask you to construct the step transition table. This is the one. And part B, construct the step transition table and the step transition diagram of the corresponding deterministic finite step machine. So we need to find the deterministic from this table. Okay, so we convert to the deterministic table first. As yesterday, we will try to see what are the steps we have after the input A and B. Okay, so we write here. Then the first one we will start for the. Do we need empty set? Not necessary. If not necessary, then you can ignore it. So for this one, we will start with Q0. Every time when you convert, you can put it in the bracket. So Q0, you look at this. The input A here, you have Q0, Q1, right? You just write Q0, Q1. And after that, for the B, we have Q0. So now the Q0, Q1 is the next step. So you continue here. After that, you will have the input Q0, Q1. And to do the Q0, Q1 input A, so you need to combine these two, right? Q0, Q1. So you will have Q0, Q1, Q2. And for the B, you have Q0 and Q2 here. After that, you already have Q0, Q1, Q0, Q2 now. So Q0, Q2, combine these two after input A. So we have 0, 1, 3, Q0, Q1, Q3 for Q0, Q2. And for the B, we have Q0 and empty set. So we have Q0. Okay. Then after you have Q0, Q1, this one is Q0, Q2. Then next one, we will continue with 0, 1, 2. So from Q0, 1, 2 here, these three, if you combine, you have 0, 1, 2, 3. For the input A. And for 0, 1, 2, for input B, we have 0 and 2 only. Okay. And continue until you have all the input A and B here. So 0, 1, 2 after that is 0, 1, 3. So 0, 1, 3, you can have input A is 0, 1, 2, 3, right? And for input B, 0, 1, 3, so we have 0, 2, 3. 0, 2, 3. 0, 1, 2, 0, 1, 3. All got already, right? 0, 1, 2, 0, 1, 3. What else? 0, 2, 0, 3, 0, 2, 0, 1. 0, 1, 2, 0, 1, 3. Okay, then now we have what? 0, 2, 3, right? Okay, So 0, 2, 3, we have 0, 1, 3. And for the input B, we have 0, 2, 3. So 0 and 3 are. Okay. Now we have already the 0, 2, 3. So now we left 0, 1, 0, 1, 2, 3 here. And 0, 1, 2, 3 combine all, also get 0, 1, 2, 3 lah. Then for input B, we have 0, 2, 3. Okay. 0, 2, 3. Okay. 0, 2, 3 already have. So now left this one, last 0, 3. 0, 3. So we have 0, 1, 3. And this one 0, 3, we have 0 and 3. So all included already. 0, 1, 3, 0, 3 already have. No more, right? So this one you will get it as deterministic already, meaning that every step when you plot or you see the input A and B, every step they will have one input A and one input B. Go to another step. Okay. Question. Why not the Q012 first, the sequence 012. 012. Here 012.
As in like, which one do we choose to move down first?
As long as you see your input here, right, you have what input A and B. After that, once you have, then you can move already. You can write here already. Either you put the 012 first or 02 first, it doesn't matter. I will put I put the 02 because I see that there are two elements only. So I normally for me I will arrange it in 2 first, then 3 instead of go and do the 2, 3, 2, 3 like that. If possible, I will arrange in the less to more elements inside. Like this one, no choice because the Q3 only appear after this, right? So then I can only write it after Q1. Q1 do we have? We don't have here. Then you see the input AB here, you don't have. Even you put the Q1, right? Then you need to put Q2 already. Then Q3 and Q4 also. Not necessary lah, because in the A and B here, we don't have after input AB, we don't have Q1. So if you put Q1 later on when you grow, right, you don't have any input go to Q1 also. So it is actually redundant. Okay? Understand that? Linkit Linkit, you see, you don't understand that. Today you attend or not? The first lecture, do you come yesterday? For this chapter? Huh? Got. Then, what do you don't understand now? Ask the question. What do you don't understand? Jackson, you understand your question already or not? Jackson, your question okay or not? Why you don't answer? You don't understand? Okay. Understand, ah?
Can you explain?
Yes. Okay. So for this one, if you to see that the input A and B here they don't have the step, right? Then you can ignore it now. No need to put it here because if like this, Q1, Q2, Q3, a lot we need to put 2 power of 4, you should have 16 altogether if you include all, right? And actually, it is not necessary for the redundant step. So for this one, the question here, table, right, already done. And they ask you to draw the step transition diagram. The step transition diagram of the deterministic, meaning that we need to draw this one. This one. Do you need me to draw this? Need me to show you the diagram or not? Or you can draw yourself? This one? This alone? Assignment? If the question didn't ask like this, only when the question said draw the step transition diagram, right? Of the deterministic, then you need to draw. If they didn't ask you to draw the diagram, then you don't need to follow the question. Now my question is, do you need me to draw this? If yes, I will open the Jamboard. Yes, or you draw better. I open you draw. Okay, use your pen to draw.
Miss, why we choose Q0 not Q1 as a it's because we input after input A we got Q0 and Q1.
Mm-hmm. No, Q0 is the starting point, So every time we need to start with the starting point. Cannot start with the middle one. Even you go to Q1, what do you get after input A? You will have Q2, Q2 and Q2, right? So the starting point you must start from the starting point. If the empty set don't have any input here, you can ignore it out. But if you have any input for empty set, let's say you have Q2, right? Need to go to empty set, then you need to include the empty set also. But the starting state, we need to start from the Q0. Okay? Nobody draw. That can view, cannot draw. See? Just now I already share. Let me see. Only view. Okay, let me change. Editor, viewer. Okay. Viewer and commenter. Click wrong. Now can or not? Can edit already? So you can draw here. Anyone want to draw can draw here. Any slide you want to draw also can. Different people can draw a different slide also, no problem. Nobody draw one. I am at the first slide. Where are you? I also cannot see you. Your friend also cannot see you. Why are you shy? What do you sign with? Huh? Even your hand when you draw also I cannot see. The class also can come out to do already. Nobody want to do Then we do together lah. Draw lah. You all have pen tablet, I know. So we need to have Q0, a very big graph diagram here. Okay. Q0, Q1. Oh, done already. Bigger a bit. Okay, let's see. All the bracket already eaten already. Q0. Q0, Q1. A, B, go to Q0. And then Q0, Q1, go to Q0, 1, 2, and 0, 2. 0, 2, go to 0, 1, 3. 0, 1, 3, and Q0, Q0, 2, Q0, and then 0, 1, 2, go to 0, 1, 2, 3, and 0, 2. Where is the B for 0, 1, 2? Q0, 2. One more here, right? Zero, 1, 3, we have 0, 2, 3. 0, 2, 3, we have 0, 1, 3, and 0, 3. Okay. 0, 1, 2, 3, 0, 2, 3. Okay. This is 0, 1, 2, 3, right? Input B go to 0, 2, 3. This one 0, 2, 3. Yeah, this one. This is extra already. Yeah. Then 0, 3 go to 0, 1, 3. This is A, and 0, 3 B. So the A and B, write it at the right position, the A and B. Like this one, the B, right? Don't write near the A here lah. So you put the B up a bit, okay? So that we won't be confused with the position. So this is the diagram for deterministic finite state machine. Empty set no need here because the input for all the steps we have don't have the input empty set. We don't have input empty set, so no need lah. If you have other step that need to go to empty set, right? Then only we put it there lah. So this one, the acceptance step is Q3. So that means all the Q3, as long as they have a Q3, right? We will put a double circle to all this. And also the bracket, this one is a non-deterministic to deterministic, right? So every step must have the bracket. Okay? So you need to add in all the step with the bracket to show that it is a step in one group. If not, if you write like this, Q0, Q2, it considered as two different steps already. Okay? So this is the diagram for the deterministic finite state machine. And this one done already. Okay, so we still have extra example. So for non-deterministic, do you still have question? Non-deterministic? Okay, ready, And for the extra example, we have this one. Actually, yesterday I also showed you one already. This is the same also. Construct the state transition table of M, tabulate the word transition function for the original machine, and also find the partition with as few classes as possible, and then draw the state transition diagram for the caution machine and move out. Okay, so I believe you also know how to do it already. Now we will divide with acceptance and non-acceptance steps. So S0, 1, 2, 5, 0, 1, 2, 5, and S3 and S4. So this one, the table, copy to the Jamboard or not this question? Just copy the diagram. Then copy the second slide. Anyone copy the question diagram to this? So I will just convert to the table first. I find the partition 0, 1, 2, 5. One, two, 5, And then you have 3 and 4. They are the acceptance set, right? So the input now is 0 and 1. So S0 after input 0, what do we have? S1, right? Zero, S1, S4. S1, we have S2 and S4. And then S2, we have S0, S4, S5, 0, 4, S3, 4 and 5. And for S4, we have S3 and S5. Alright. So now we will see that the input 0 and 1, right? After input 0, here the group is 0, 1, 2, 0, 1, 2. So 0, 1, 2 is actually in the same class, which is the non-acceptance set. And for the input 1 here, all are 4. These are all 4, right? So they are still in the same class. This one 4, 3 also same class. This one 5, 5. Did I write something wrong? 0, 1, 2, 5. 1, 2, 0, 4. So S5 is S4 and S3. S5 is S4. Okay. Is it correct? The diagram very small. S5 go where? S0. Correct now.
S5, one input is go to S3.
This one, this one, where is S5? Oh, this is S5 is at the right side. I see wrong already. That is S3. So S5 go to S4 and S3. This is S4. Then
Miss,
S3 go to
3
0
after
and 1.
input 5 is going to S5.
S3. This one also wrong already. Just now I see wrongly S3 and S5. So the S3 go to 0 and 4, right? This is S3, 0 and 4. Correct already, S4 go to 5 and 3. 5. Then okay, so here, after we get this, which one not in the same class? the 1204 here after the input 0, you see this one 1204, 120 in the same class, but S4 is the different, right? So that means we need to subtract the S5. Okay, take out the S5. So in the next table, we will have 0, 1, 5, 0, 1, 2, and then this one S5 take out, then this one S3, S4. So here still is 0, 1. So S0, we have S1, S4. S1, we have S2, S4. S2, we have S0, S4. S5, we have S4, S3. S3, we have 0, 4. And this one is 5, 4. Okay. So now we have 3 classes already. And we need to subtract any more. 0, 1, 2, same. This one, 0, 5, is it the same? 0, 5, different, right? 0 is here, 5 is here, right? So we still need to do one more class split. We still need to split the S3 and S4. Split. Okay. And here we have 0, 1. In this case, we have 1, 4, 2, 4, 0, 4, 4, 3. S3 is 0, 4, then 5, 4. So you can see that all are remain in the same class already after input 0 and 1. So this is the answer for part 3. Find the partition. Find the partition of the state set corresponding to the machine components with as few classes as possible. This is for part 3. S4 input 1 become S4. Not correct. S4 here input 1 become what? S3. S3. So this one is here S3. S4 input 1 is S3, right? Correct. The S4 and S3 are in the same class, but 0 and 5 are different class. That's why we split the 3 and 4. Okay. Any more? Then you can draw already, right? I think other part you can do already. This one, the tabulate the word transition function of F0, 1, 1, 0, 1. This one you put all the step, find all the steps and draw the step transition diagram with the quotient machine. So you already divide, just now already divide to 4 classes. Then you can take from here, draw the diagram. You can do the table first if you want. So you will have 0, 3, 4, 5. 4 classes. You can have S0, S3, S4, and S5. 4 classes. Then what happened after input A and B? S0 after input A, it becomes 0 is S1, S1 in the class of S0, right? So this is 0. S4 is in the class S4. So we have S0 and S4 for S0. Then for the S3, we have 0 and 4. Then S4, we have 5 and 3. And the last one, S5, we have S4 and S3. Then you can draw the diagram referring to this table. You can draw, right? Okay. What is the answer for this one? Tabulate the word transition function, the part 2. What is the answer? 0, 1, 1, 0, 1. F 0, 1, 1, 0, 1. Can give me the answer? What is the answer for S0, S1, S2, S3, S4, S5? First one answer is 0, 1, 1, 0, 1. So we have 0. This is, oh yeah, 0 and 1. Okay. So 0, 1, 1, 0, 1. Okay, 0, 1, 1, 0, 1. S3, right? 0 is 1. Then 1 comes to S4. 1, S3. 0, S0. 1, S4. Right? So the first one is S4. And then for S1, we have 0, come to S2, 1, 1, S4, S3, and then 0, S0, and come to S0, 1 is S4. S2, 0, 1, 1, 0, 1. So S4, right? And what is the answer for S3? Give me the answer. Oh, I do only. Did you try also? 0, 1, 1, 0, 1 for S3. What is the answer? S1? S3, or start from S3. So we have 0, 1, 1, 0, 1. S4, S4, right? Try for S4 again. Start from S4 now. What's the answer? S4? Hey, nobody doing it. S3. Okay, so S4 is S3 and S5? Also S3, yeah? Okay. Okay. So that is the question for part 2 lah. Then done already. And the last question, extra example 2, is the same also like the example 1. We need to divide because here you have acceptance set and non-acceptance set. So here is 15 and 20 for the acceptance set. 0, 5, 10. This is the non-acceptance. Huh? So we will put 0, 5, 10 in one class, 15 and 20 in another class. Huh? So put the 0, 5, 10, and then 15, 20 in different class. Huh? The input is A and B. So 0 after input A, we have 5 and 10. 5 after input 0 A is 10, 15. 10 is 15 and 20. 15, we have 5 and 10. 20, we have 5 and 10. Okay. So here the 5, 10, 15, the different class is 10. Because 5 and 10 are in the first class, 15 is in the second class, right? So we can split 0, 5 to one class, 10, one class, 15, 20. AB. So for this, 0 is 5, 10, 5 is 10, 15, 10 we have 15, 20, and 15 we have 5, 10, 20 we have 5, 10. So is it all the same already? This one A, input A, you see the 5 and 10? 5 and 10, now after you split, it becomes different already, right? So that means the 0 and 5, you still need to split to different class. Okay? 15, 20. So we get this, A and B. So 0 is 5 and 10. 5 is 10 and 15. 10 is 15 and 20. And 15 we have 5 and 10. 20 we have 5 and 10. So we pick again. Now we have 5, 5, 10, 10. Okay? So all are in the different group already, right? Then continue the classes. So we have 1, 2, 3, 4, 4 classes. The question asks for what? Determine the minimum quotient machine, constructing state transition table, and draw the diagram of M. So that means you need to divide the classes. Okay. That one can do or not? Divide the classes. So we have 0, 5, 10, and 15. 4 classes. And if you refer to the table just now, A, B, the A is 5 and 10. The step 0. This is 10 and 15. Then we have 15, 15. And 15, we have 5 and 10. Right? Refer to this, 5, 10, 10, 15, 15, 15. Because the 20 also in 15, the class. Then 15, we have 5 and 10. Okay, so then you can draw, refer to this table. And for this one, the question here asks for whether it is the final state machine, where the initial state is S1 and the input set XTUW, determine which of the following input string are valid. Meaning that which input string will reach the acceptance step. Okay, the first one can reach acceptance step about XTUWT. XT not valid, this one cannot, the first one. Okay, because XT then cannot have U already, right? So this is not valid. Second one, XUWX. This one, they ask you to give the reason if not valid. How do you want to write? Because after the T, right, XT, we don't have input U. No input will accept T will follow by input U. No input that accept T will follow by input U. Okay, that's why it's not valid. Then XUWX, XUWX equals to S1, isn't it? So this is also not valid because it is not acceptance step. S1 is not an acceptance step. Then the rest, XUWT, you can see XUWT, okay, this is valid. Then for the fourth one, XXXUWT, 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 also valid. And the last, XTXTXU, XTXTXU, and then WXXWXXU. Okay, go to S4 also, right? So this is also valid. So you try see whether you understand that. And then you see you can understand or not, the answer there. See how many already taken. Brandon here?
Yes, miss.
Okay. Brian? Kai? Send faster. Don't raise hand. Send. Yes. I cannot see your raise hand.
Yes.
Kai? Yes. Here? You just type in the chat. Kayao? Jixin? No. 2 seconds. If not, no yes come out, then no. Junbin? You prepare your chat. Yes. Then I call your name. Just send only. Junbin? No. Weifeng? Ian? Weifeng. Not Weifeng. Weifeng not here. Ian not here. Jia Seng?
Present. Xian is present.
Ian, Jia Seng. Okay. Min also.
Yeah, June Miss
Yes.
first.
Minky. Fast.
Yes, Miss. Yes. Yes.
Minkan.
Yes.
Yuchun. Eric.
Present.
Changhang. Lisong.
Yes,
Ning.
yes.
Ning. Jackson.
Yes, President.
Hai Xiang.
Yes, Miss.
Hai Xiang à? Chi Xuân. Chi Xuân.